Hi everyone, today I want to take this opportunity to introduce Hiossen ET3 implant surgical kit. Many of you are using Hiossen ET3 system or many of you started using them, and there are some key features I wanted to highlight in this short video, and what makes ET3 unique and how to really maximize the benefit that this special features that ET3 has. Okay, like many kit, it is a color coordinated system. Okay, you have implant diameter which is a 3.5, 4.0, and a 4.5, and a 5.0. So those of you who are familiar with a Nobel Biocare or other system with a color coordinated, so this is no different. Okay. 4.0, 4.5, and 5.0, these diameter implant will share the exact same internal hex connection, which is going to be shared among three of them. Okay, so you don't have to have a different healing abutments or different impression coping for these three. However, 3.5, which also is known as a mini diameter, 3.5, it has its own unique internal hex connection. Okay. Now, ET3 implant system is what we call bone level implant system, meaning that when you place the implant, you want to sink the implant at least to the bone level, or ideally slightly below the bone level. Okay. The reason is that its unique feature of open thread design that goes all the way to the top of the implant. Thereby, when you countersink the implant to the bone level, you optimize the chance of bone level maintenance at that level. And this is a platform shifting implant design, so thereby, by countersinking the implant fixture to the bone level or slightly below, again, you are maximizing the benefit of platform shifting. All right. Now, because of that, this implant system has a unique implant drill shape and the length. Let me explain that to you. For example, when you have a implant that this twist drill is a, let's say, 7 millimeter length twist drill. When you look at it, let's look at it this way. There's a line, okay? The top line over there, okay, that marks the 7 millimeter depth, but the stopper is a little bit higher than that, which makes the entire length of the cutting surface, okay, when you sink this drill, okay, the stopper will prevent you from drilling any further. However, the length of the drill now is no longer 7. It has a built-in countersink depth of 1 millimeter. So that makes the entire drill length to the stopper 7 millimeter plus 1, which makes it 8 millimeters, and plus the cutting edge surface, which we also call it a Y factor, it makes the drill length a little bit over 8 millimeter. The reason for this is so that when you place a 7 millimeter depth implant, okay, and when you do the osteotomy sequence of this with a stopper, you will always be able to put implant to the bone level or slightly below the level of the bone. Okay, so it is, you never have to worry about implant not sinking in all the way down. So that is a very unique feature. But you need to understand this, so that when you are drilling that the depth of the osteotomy is always going to be slightly deeper than the implant that you're placing, okay? And that is true with any other length. For example, this implant drill, which is a 3.5 by 10, once again, you have a length of a drill, the black line represents the 10 millimeter, and then there's another a depth of another millimeter before the stopper, okay, that's another millimeter. So thereby it makes this drill 10 plus 1, which is 11 plus the Y factor. So slightly longer than 11, okay? All right. Now there are going to be situation where that you're a little close to the nerve. For example, you know, maybe from the crest of the ridge to the level of the infraalveolar nerve is about 11 millimeters, and you want to place, let's say, 10 millimeter implant. But then in order to place 10 millimeter length implant, you will need to use this drill that makes the depth 10 plus 1 makes an 11, and that's a little bit too close to the nerve, and you don't want to do nerve damage. So what do you do in these cases? What you can do is you can easily use the implant drill of 8.5, which has a 1 millimeter counter depth, so that makes this implant drill 9.5 plus the Y factor, that makes it almost 10. You can use drill to the level of the bone that will give you close to a 10 millimeter of depth, okay? And then you can either choose to place an 8.5 millimeter length implant, or you can use a 10 millimeter length implant. Of course, the only difference is that when you put 8.5 millimeter length implant, it'll be countersunk about a millimeter, whereas when you put a 10 millimeter length implant, it will be to the level of the bone. I hope that makes sense. Okay. So the most important thing is that each of these drill, whatever the number indicates, when you drill to the height of the stopper, okay, is add another millimeter. Okay, so that's a very important feature. All right. Okay. So how does this drill system work? Very simple. Like any other system, you start with the lance drill that marks the spot, and then from here you can go into the twist drill. Now here the twist drill, pilot drill is 2.2. I usually use a 1.5. Okay, twist drill before I go to 2.2. Okay. Anyways, once you reach a 2.2, then you can choose the depth of your desire. Let's say, for example, I want to place a 4.0 by 10 implant. Guide drill, and then 10 millimeter twist drill, which will give me 10 plus the added 1 millimeter to the stopper countersink depth. That would make it 11. Okay, and then from here, you can go to the 3.5 by 10, and then 4.0 by 10. Okay, so that will give you 4.0 by 10, and then you can place your fixture. Okay, so that's a cookie cutter ABC step fashion. If you want to place a 5.0 by 10, basically you repeat same thing. Lance drill, and then 1.5 twist, and then 2.2 by 10, and then 3.5 by 10, 4.0 by 10, 4.5 by 10, and 5.0 by 10, and the implant goes in. Of course, if the bone is soft, you'll probably stop on diameter 1 shy of the proposed fixture diameter. You'll stop at 4.5 and then put the 5.0 diameter implant, okay? Because we do want to go and achieve the stability of a 30 Newton centimeter torque, okay? Initial stability, all right? Now, once that's done, you can use the mount driver to pick up the implant and place the implant in the osteotomy site. If you're using the fixture with the mount, I highly recommend ordering and using the fixture ET3 fixture, the implant with the mount already attached. Okay, you'll love it, especially when you're doing a multiple implant cases. That having that mount is very, very helpful. Now, some of you who don't like to use the fixture with the mount, okay, you can use the implant driver to pick up the fixture directly and then place it into the osteotomy site. Okay. All right. Now here's also a mount extension, okay, also a fixture driver, okay. So you know, rather than explaining every little component, I think it would be easier for me to do a little demo of placing a molar implant on a dental form, okay? Okay, let's begin the osteotomy. So the first drill is going to be precision drill, or also known as the lance drill, and it's got this sharp point edge that makes it to be an ideal first drill, so that your initial osteotomy is precise in position and it doesn't slip away. Okay, of course with a precision drill you don't have to go to the depth of desire. You just need to go maybe about 1 millimeter or 2, that's it, to break the cortical. And because our proposed final implant is going to be 4 by 11.5, 11.5 is going to be the drill, okay? But before I use a 2.2 twist drill, I like to use 1.5, okay, twist drill, okay? And then I can go with the 11.5, 2.2 by 11.5 twist drill. And if you're always wondering, unsure about actual size of the drill, you or your CDA, if you look carefully right here, it says 2.2 by 11.5. Every drill has the laser marking of its exact length and the diameter, okay? So that your CDA, when they are sterilizing and reorganizing the drills, make sure they look at this and then put it to the right slot. So 11.5, okay. I do all my osteotomy at 800 RPM or less, okay. Slower the better. So you can check the depth of the osteotomy with your depth gauge, and as you can see, it's actually slightly deeper than 11.5. It's actually 12, okay, or 12.5, or you know, so it's definitely deeper. So 11.5 drill takes me additional millimeter, that's 12.5, and additional Y factor, okay, call it a 0.5 millimeter. So that takes you almost 13, okay, right? That's the point I'm trying to make. Next drill, 3.5 by 11.5. Okay, the stopper automatically stops. Okay, that was a 3.5, 11.5. And the next drill is the same length, 11.5, but width is 4.0. Tapered step drill. As you can see, it's not total taper, it's actually stepwise. This drill shape helps to establish initial stability when you place ET3 tapered implant. Okay, so this will be our final drill size. Okay, there you go. So the osteotomy is done. And then next, we will change our RPM, okay, to 30 Newton centimeter torque, and we will deliver our implant. When you get your implant, now this is a dummy implant, okay, it's for the model use, but the real implant packaging is very similar to this. Your CDA will open it and drop it in the sterile field, and the doctor, you will pick this up, turn it, the canister, and here's a fixture, okay? Now this is a dummy fixture, the color is dark blue, but your real implant is going to have a very gray, whitish, sandy surface, which is very typical of the famous ET3 SA surface, double treated. So it's a sandblasted and acid etched. They call it an SA. Okay. So how do you pick this up? You need to pick this up because it has a mount. Because as you can see, you have this green mount. Okay, green stands for the internal connection regular platform, which is shared by 4.0, 4.5, 5.0 diameter implant, and also the ultra lineup of ET3 molar implants, which is a 6.0 and 7.0. Okay, so how do you pick that up? Because it's a mount, you're going to use the mount driver. Okay, as you can see here, that's a mount driver. And what you do is basically you grab this like that, and how do you take it out? All you have to do is just flip. That's it. Okay, no way of accidents happening. Okay, and at your RPM, you're going to place this in the side. My recommendation is before you put your implant, try to wet the implant surface with the saline. Okay, before you introduce into the bone. Okay, that's just my recommendation. Okay, so I'll wet this with a saline, make it wet, and then I would gently introduce into the site. There you go. That's the torque. Okay, now when you place this, you don't want to put the implant all the way to the level with the fixture mount. Okay, because when that happens, if it goes too deep, you try to remove the mount, and sometimes the mount is stuck underneath the bone. Okay, so what you want to do is leave the fixture about a 2 millimeter above, and then switch over to fixture level driver. Okay, all right, fixture level driver. All right. They come in a different diameters. Diameter that we're interested in is a regular. Okay. And you want to use a torque ratchet to basically torque it in. And we are already at, as you can see, well over 35 Newton centimeter torque. Okay. All right. So the fixture is in, nicely countersunk. It's countersunk about 0.5 millimeter below the crest of the bone. The reason for that is the drill length that we've chosen that corresponds has a 1 millimeter countersink depth added to it. Okay, which is a good thing in general, but if you had to drill close to the nerve, you might be drilling a lot closer to the nerve than you would expect. In those cases, you need to step back on one size. All right. Okay, so from here, what's the next step? You have to choose a proper healing abutment. Even though the 4.0, 4.5, 5.0 diameter implants all share the same platform, but depending on the shape of the molar crown or the abutment, you can choose the different diameter healing abutment. For example, if this same implant was placed for the premolars, okay, I would use something like a 5.0 diameter healing abutment. But because I used it in a molar area, I want something a little wider, such as a 6 millimeter diameter healing abutment, or sometimes even something wider like a 7.0. Okay, that's another beauty about ET3 system. They have a wide healing abutment that will accommodate a wide base design of the emergence profile of the abutment for the final. Okay, so when for typical a case like this, I'll use a 6.0 diameter healing abutment with 5 millimeter height, so basically 6 by 5, and then once the area is ready for impression, they have a matching impression coping, which is the same diameter, and then they also have a matching stock abutment if you choose to use a stock abutment. Now, many of the Hiossen users are using a SCRC, a custom CAD/CAM titanium abutment anodized together with the zirconia crown. Okay, that seems like the way to go. Okay, but if you did want to use stock abutment, you may do so. They have a very nice stock abutment lineup also. All right. So that brings us to the end of the kit. Now there are other small little area, kit that I haven't covered. For example, driver for the Mini. Okay. Things like HS3, which you'll never use because HS system is not available in Canada. And there's also a retrieval tool here, which you will rarely use. And there's this line here. Let me remind here though, okay. If you ever encounter hard bone, like a D1 bone, dense bone, after you finish your osteotomy, you're going to have to open up the coracle plate with these special burrs, okay. These are similar to the use of what we call a tapping drill, okay. Tapping drill to make the bone softer, okay. You rarely have to use this drill for the ET3. I think I've only had to use it twice in the past couple of years, okay? Because the ET3 implant itself is a self-tapping implant, okay? So you rather undercut it, under-prepare it, and let the implant do the final cutting as the implant is introduced into the osteotomy site. These are parallel pins or guided pins when you're taking a PA to see the direction of the implant at the initial stage when you're taking x-rays. It also comes with the drivers, 1.2 length and 1.2 diameter, short and long. Okay. You got other drivers here, okay, for the torque ratchet. So it's got a lot of many small parts, okay, but it seems a lot, but it makes perfect sense, okay. Yeah, so that takes us to the conclusion of introductory to an ET3 system. Hope you guys enjoy it. Next 1-point relay goes to Dr. Albert Louis. We've always enjoyed his OPR. So, good luck, Albert.